explain the homework question if you tried it. We call them truncated. So if you hear truncated, means like something is chopped off. Okay. The original has been like, and so if you think about it, what does that look like? Something you use quite often. Doesn't it look like a cup, right? So sometimes it might ask you, hey, find the surface area of that cup, but we don't have a formula for that shape. Okay, this is on page 19. We don't have one. It kind of looks like a cylinder, but it's not. It kind of looks like a cone, but it is not. So you kind of have to imagine that this thing continues. So we kind of deal with the large cone and the small cone. We kind of do something with that to make it work. All right. So let's figure out this. I'm going to call this capital R. So half of 3.25 is 1.625 inches. We don't round, okay? Lowercase r for that small circle is 0.5 inches. Okay, so you've got that. I'm going to tackle surface area first. Because if time runs out, volume, I'm pretty sure you figured that one out. It's just volume of the large minus volume of the small. Okay, so let's go with total surface area. I usually tackle the biggest shape first. Okay, let me zoom out a little bit just so we can have it all in the same frame. We're going to go surface area of the large cone. So I'm imagining this large cone right here. If you'd like to highlight, I'm just going to show you that it's this one here. Okay, the large cone right here. So that's what I'm doing first. And then what? I'm going to subtract the lateral surface area of the small cone. Why lateral surface area, Mr. Dirksen? Why not the whole cone? So I'm going to try something here. Okay, this is the small cone right here. You know the paper cups that are actual cones, right? The really cheap ones, flimsy ones, right? If you imagine one of those and you were to take scissors and cut the bottom off, right? It would be hollow, right? Water would fall right through. So that's kind of like the idea here. I take the large. So we're imagining this is closed up top. We're not saying that this is a cup. So we're going to do this and the entire surface. So we're talking the entire surface area of that big cone. I subtract the lateral surface area of the small cone. So I'm just going to take off the side here. This is not there at first. Okay? So now I have that. Now I'm going to go plus area of a small circle. And what color have I not used? So this one right here. That's how I'm going to tackle that one. Okay. Okay. So let's get this started. Surface area of the large cone is it's pi r squared plus pi rs. I'm going to put this in square brackets. That's the surface area of the large cone minus the LSA of the small cone. So I'm just going to go pi rs. I'm going to go small s there plus pi r squared. So I'm going to use a lowercase r there because I'm dealing with this circle right there. You're good? Question before I move on. If this had been actually a cup, would this circle have to be included up here? No, it would be hollow. So what would change in our formula here? We would actually not include that big circle up there, right? So this part would be omitted. So you have to read the questions carefully. It's not a one-size-fits-all. Okay, so pi 1.625 squared plus pi 1.625. What's the slant? Capital S. Look up here real quick. I'm just going to call this like, this is capital S. And I need my lowercase s. What is that? If I have this piece right here, how would I get the slant of just the small cone here? Minus. Yeah, so I'm going to do that on the side here. Maybe here. 7.85 minus 4.32. That is 3.53 inches. So that is the number that I'm going to assign to lowercase s. This one is a little bit overkill. There's a lot of unknowns. Most of the time there aren't that many moving pieces. Okay. So let's keep going. Capital S here is 7.85. That all will go in square brackets just so we understand we've taken care of the large cone. Minus pi 0.5, and here is the lowercase s. Since this has a bottom, right? That's all the solid lines indicate shapes that are actually solid, okay? Plus pi r squared. There you have it. And now let's clean this up. You realized how important it is to type in the numbers correctly, right? A lot of you may have had an issue here or there. So pi times 1.625 squared. I'm going to put that in my calculator like that. Hit equals because then you can just copy paste. I hit equals, so I have these two numbers. I would say it's a very good idea to just actually write down these numbers. If you need to backtrack, even if you hand in work. Yeah, go ahead. Minus this part right here, you're just gonna have to take my word for it, is 5.54. That one right there. So if you want arrows, you go for it. Plus pi r squared, which is 0.78 something. And it actually keeps going. All of these numbers keep going. If you were to add and subtract accordingly, you end up with, so loud in the halls. My cabin was always nice and quiet. So that's your total surface area, including, we're assuming that the top, like the big circle and the small circle, are both included here. Let's do the volume before we go. That'll be it for today. And then tomorrow we're going to start bigger renovation, like we're going to excavate, we're going to build gardens, we're going to plant seed for grass. You look very excited, I know. You can't wait. All right, here we go, volume. TV. I'm just gonna say volume of the large cone minus volume of the small cone. Just make sure we don't have a formula for this weird shape that is the result of cutting off the little cap here, right? We don't have one. So some students try weird things, and it doesn't work, okay? So volume of large, so that'll be pi r squared h divided by 3 minus pi r squared lowercase r lowercase h divided by 3. If it's a slanted shape, guys, it's going to be divided by 3. So pyramids and cones. We have a problem, right? We don't know the h's. We don't know the heights, okay? So I'm going to do that. I'm going to try to fit that in on the sides here, right here. So if you think of the big height, right, that goes right from the top straight down to the tip here, we know that this is 7.85 and this is 1.625. It's basically the radius goes over there. So you have your hypotenuse. So I'm going to call this capital H. Mr. Hertzen, H is always the hypotenuse. Not in this case, okay? H. Try to write this down. H is 58.98 something. H ends up being 7.67 inches. Okay, important. I'm going to do the same thing with lowercase h, okay, from here to here. Just stay with me, okay? I'm going to try to hurry. 0.5. The slant is 3.53. And this is lowercase h. Lowercase h is square root of 3.53 squared minus 0.5 squared. I'm just going to give you the answer. H is 3.49 something inches. Also important. I'm going to stop there. I'm going to pause this because I know some of you are thinking, if you want to do this yourselves, you know that this is the answer you're supposed to get after doing this. Okay? Thank you, guys. All right, we're just going to finish this one here. We already figured out the two heights in class. So there's that lowercase height and the uppercase. Let's see if I have a different color here that I can use for that one. There you go. And so we just plug in and go. Pi 1.625 squared times 7.6 something divided by 3, don't forget that, minus pi 0.5 squared times the height lowercase of the small cone, dot, 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 don't forget that, divided by 3. If you plug this in correctly, you get 21.23 something. If you plug that in correctly, you get 0.91. And your total volume ends up being 20.32 cubic inches. So we did the volume here. A lot of moving pieces, but we got it done.
Just a reminder to all students.